So let us start. I hope that I am visible, audible, as well as you can see me, you can hear me. I think everything is working fine. Could you please confirm once that you can see me, you can hear me, as well as you can see the slides just once? Very sorry, I think I got disconnected. I'll just reshare everything. Yes, could you please confirm once that you can see me, you can hear me, as well as you can see the slides? If everything is fine, then we can start. Yes.
Yes, sir, you can see.
Oh, oh. Then let us start. So, very good afternoon, everyone. My name is Ambuj. I am research scholar at Agriculture and Food Engineering Department from IIT Kharagpur, and this is the last session on 12th October 2025. That is the summary session in which I will be summarizing all of the content which I have yet discussed from week number 1 to week number 12. I'll try to be as detailed as possible. This is the first part in which I'll be discussing various concepts in brief. And after that, we'll be going through this particular PDF in which I have summarized all the formula, okay, which is very, very important for your examination. Okay. So we'll try to cover both of these things in this particular summary session. Okay. And please take a notebook, pen and paper. That is would be very, very beneficial for you. Okay. Because a lot of things would be new or a lot of things you would like to keep a record of them. Okay. Will you be sharing the PDF? Yes, I'll be sharing both of the PDFs with you. Okay, why not? And once again, I'll give you the link also. Just 1 second.
That link are same as previous link.
Yes, yes. That link is same as previous link. In this link, I'll just open. You can find here in the second rows, my name is there. Along with it, the YouTube links are there. Along with it, the drive links for each and every presentation which I have taken is already mentioned here in and the collab notebooks also. Okay. So within the same drive link, I'll be sharing this PDFs. Okay. So sincere request to you is that if you have missed any session, please before the examination, go through the lecture recordings, lecture PDFs. Okay. And one more request is there if you are having any doubt at any point of time, please utilize these 2 hours to the maximum extent because after this you won't be seeing me. Okay. So this is your last chance as far as I can see. And yes, I'll be sharing my mail ID also before the examination. If any doubt is there, anything is there, then feel free to contact me. Okay. As well as in future also. Anything is there. This is the mail ID. Okay. Do note it. Very simple mail ID is there. Okay. So thereby you can contact me and feel free to ask any of the doubts if any in future also they emerge, then you are welcome. Let us start. Okay. First of all, what is computer vision? Computer vision, as you already know, and you must be well aware that there are only two terms, computer and vision. Okay. So the vision characteristics which have evolved, okay, over the period of time in nature, they have already existed as well as our vision system. Okay, vision means and the way in which you perceive or you see things, that is vision. Okay, and computer means how a machine which is named as computer, okay, it can see. So that is the thing. Computer vision is a field of AI that enables the computers to interpret and understand the visual information from the world. Okay, it will involve automatic extraction, analysis, understanding of useful information, images, videos, and it is inspired by nothing other than HVS, Human Visual System, or Human Visual Perception. That is in brief regarding computer vision. What is the definition and what it wants to say? Okay. So it is nevertheless asked in interviews, but sometimes if the interviewer finds it interesting, then he might ask that explain the term computer vision in your own words. So thereby, in response to that particular question, you can say that computer vision is a field of AI which enables the computers to interpret and understand the visual information from the world. Okay. If any another definition comes to your mind, feel free to ask it. Feel free to express. Okay. But one more thing, okay, because since it is the last session, so I'll try to give as much information as possible in 2 hours. Okay. See, I am personally in presently pursuing PhD, and I have taken a lot of interviews as well as I've myself uh, appeared for a lot of interviews. Okay, and worked also in different domains. So from my experience, I can say that whenever a question is asked to you when it comes to interviews, okay, then in that particular cases, in those particular cases, okay, the very first thing which you have to say is never use the words like basically, maybe. Okay, these are the words, or as far as my knowledge, this word is it is far good. Okay, you can take it. As far as my knowledge, okay, this is good. But when you are saying basically, when you are saying maybe, okay, it particularly highlights that you are not knowing or you are not sure. Okay, so wherever you have to say anything, okay, whenever you have to attempt to talk about anything. For example, if it is asked that explain about yourself, okay, or if it is asked that explain, give your introduction, okay, according to you, who are you, okay. So in any of those cases, never use maybe, however, basically, okay, these type of words. Be confident, okay. You should sound confident, okay, whenever it comes to an interview, okay. You should sound confident, and it depends on the other person's perception that whether he likes your definition or he approves your definition or he takes you into account only on the basis of body language and on the basis of whatever you are communicating. So focus on your communication skills. I have seen a lot of people, they are having a lot of knowledge, okay, but when it comes to communication, they fall behind, okay. Those particular cases, one basic thing which you can always incorporate, never use maybe, basically, okay. And when you are stuck in something, okay, you are unable to answer, then you can say that, sir, as far as my knowledge is concerned, I know this much, okay. So in that particular form and manner, you will not sound arrogant also, and you will be coming out of the conversation also, okay. So these are some basic tricks which we apply, or basic things we apply, okay. So this you shall know, okay, you must know as a student, okay, because in whatever domain you would be stepping into, and in whatever field you would be joining, one basic thing would be always constant, that you have to appear for interviews, okay, multiple interviews, okay. And one more advice, that sometimes I've seen even toppers of the class, when it comes to Viva, what say, they are just shaking, okay, their hands and feet are shaking. Why? I don't know. It's a general conversation. Never be afraid of interview. Okay, it is same, whichever it is the same thing which you do in class. Interact with your teacher. So in the same format manner, you have to interact with the interviewer in your best form and manner possible. Okay, dress accordingly. Okay, when you are appearing for interview, and sound confident. You don't no, need not to shake yourself. Okay, that I am appearing for an interview. Interviewing interviewer will try to kill me. No, nothing will happen. Okay. So these are simple things. Okay. Because when whatever knowledge you have acquired, if you are not able to express it, then no, it is of no use. Okay. So whatever thing you have just learned in your 4 years or 6 years or even 10, 15 years of teaching and in your professional career, you just have to express it toward the other person. Okay. And these are the basic things which you should keep an account of, because I assume that you are just a junior to me. Okay. So that is why I am telling you as a friend, and as a philosopher. Okay. So these are the basic things. Yes. Anything else you would like to say, then feel free to say. Okay. Just 1 second. Let me mute you. Unmute. Okay. Yes. Very good. Yeah. So let us move ahead. Okay. Then why computer vision matters. Okay. I'll be talking you in this presentation. Feel free to unmute yourself. Feel free to talk. Okay. But meanwhile, I have just muted because some unnecessary noise would be there. Okay. So that is the thing. This is the last session, last chance for you to communicate with me. Feel free to communicate. Okay. Get your concepts cleared. Okay. And uh, I'll try to guide you in academics also and non-academics also. Okay. But interview calling comes under academics only. Okay, that is why I told you. And presently, as far as my experience is concerned, okay, a lot of people, they are very shy to communicate. So don't feel shy. Try to be expressive. Okay. Try to communicate. That is the only key which I can suggest to you. Okay. Then only your communication skill will improve. Taking courses and joining some webinars will won't help you. Okay. So try to communicate yours. That is the first and foremost thing which you can just try to achieve. Okay. Then comes why computer vision matters, because it enables automation of tasks that require visual analysis. Okay. Then reduces error and improves efficiency. Okay. See, as far as HVS, human visual system is concerned, it is having limitations. Okay. It is human has its limitations. Okay. A human being cannot work 24 into 7 without with using the same efficiency. So that is why we have tried to create the same efficiency using computer vision. Okay, so because a machine can work 24 into 7. Okay, that is the basic thing. Okay, as well as it is used across various industries, healthcare, agriculture, security, robotics, transportation, and a lot of those domains. It is getting we are getting ahead with this computer vision techniques. Okay, that is the first and foremost thing which you should understand. Okay, why we are studying computer vision. This is very very important for you to understand. Okay. Next is what is the goal of computer vision? Goal is
It's a,
very simple. Yes,
yeah.
yes.
So you are talking about some interview perspective. So
Hmm.
basically, who are taking? I not appear any interview till now in corporate sector. So basically, HR are taking some question about computer vision, or some technical person are taking.
No, actually, it depends on in which type of interview you are facing. If you are appearing for job interview, okay, then it would be a three-round process. First round would be your written test. Okay. After that, there will be technical round, two rounds or three rounds. After that, at the end, the interview would be of HR. HR will be taking your interview. Okay. So this is the three or four step procedure which companies generally do for taking judging you. Okay, and this is for job application. In the meanwhile, when you will come into the job, then whatever interviews you will be facing, they would be from HR only. Generally, okay, generally, since you are doing job, then HR would be only taking your interview. Okay, that is the thing.
If I apply for the vision related,
Uh-huh.
computer vision related engineering position,
Uh-huh.
so maybe there will be some technical round also.
Yes, yes.
So in
Technical round is a must.
technical round will be some. I have to did some what type I have to appear in the interview. So,
In the technical round, first of all, you have to explain your project. First of all, you have to explain yourself. Okay, who are you? What degrees you have done? What is your qualification? After that, you can explain what is your project, what is your planning. Okay, and what the most important thing is why you aim to join the company. Okay, these are the questions which you should be very thorough with, and you should try to make a presentation onto it, and then you should try to explain yours. This is
so in technical round, I have to just explain the project what I
you
have
have
been.
to you have to explain the project, and if some question is raised by the people, then you have to answer. Okay.
Okay. Any
Okay.
project or related to that company, depend upon the situation.
Related to that company only. Related to that company. Not any project related to that company. For example, if some company is there which is working on rubber technology, and he wants to hire you as an AI engineer or a computer vision expert, then you have to search for some project which would be beneficial to them. Okay. Then you have to make a draft, and then you have to propose an idea. Then you have to explain them that why, suppose I am the interviewer, then you have to explain me why should I hire you. Okay. So that you can explain using some project. Okay. That if I will be hiring you, then what benefits you can provide to me. Okay. That should reflect from your presentation. That is
In
the thing.
our college project, we have to give some duration that in 7 days or 10 days you have to submit that project. In interview, there will be some they are giving some time or just I have
Mm,
to do in
no, no, no.
instant.
You can explain the projects which you have worked upon previously,
Okay. Okay.
as well as some brief about what you want to do. It is not like that you have to completely do the project and then explain to them. Okay.
Okay.
Something you must have done in the past, you can explain about those projects and what you want to do. Okay. I'm not saying first of all do. First of all, get hired, have a salary, then work for them. Okay. Never work for free for anybody. Okay. Work for free only for yourself. Okay. For your own understanding or for developing your skills. In those particular cases, only you have to work for free. Okay. In all other cases, get hired. Get hired first. Sign in a contract. These are the procedures. For
Hmm.
getting hired, you have to make the presentation. You have to explain them that what project you will be doing for them. Okay. This is the thing. After that, if they hire you, then work on those projects. Okay. Because you need salary also. Roti kapda makan is very essential.
Yeah,
Yeah, these three
definitely.
things are very important. Food, shelter, water. Okay, all these things you will be getting. After that, work for them, get the project completed, and whenever you plan to leave, also get a certificate from them that this and this person has worked for this much years or on this much duration on these projects. Okay, this the company head or HR will give you, and then go for another company or another project. Okay. Even for internships also, you can do brief internships also. If you are doing some degree or if within your job also, you can do some brief internships. Various positions are open. Okay. If you are active on LinkedIn, then the various companies would be contacting you if your profile is good. So on those aspects also, you can think of. Okay.
Okay.
So you can,
I already doing an internship from ISI
yes, 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 very good, very
that
good.
related data science. I tried to choose in computer vision, but I did not
Mhm.
get that. But,
Mhm. No
but
problem. You are if you are a student, okay? So don't get bad. Don't get a bad feeling that I didn't get it. Apply for another one, okay? That is the thing. If you will apply for 100 or 200 positions, then you will be getting selected in one or two positions. Okay, that is it. Because what is the thing is that in demand and supply, these are both of the things. Okay. Demand is for one engineer and a lot of vacancies, a lot of people would be contacting on that particular position. They might be having a superior profile or an inferior profile than you. That doesn't matter. But what the thing is that you have to do your best. Okay. And when it comes to the advice in which companies you should apply, then always go for tier one and tier two companies. Okay, reputed companies on. Because if you would be accidentally or not accidentally, if you get a chance to work with them, then your learning growth as well as your financial growth would be multiple times. Okay. So this is the sincere advice to you. Okay. So always keep a note of the companies which are reputed. Okay, I need not to take a company name because right now I am working on a government platform. Okay,
okay,
so that you already know that whichever are the reputed companies. Okay, whichever the companies are there and what is their GDP, what is their turnover. Okay, so on the basis of that, choose a company, then try to be in touch with them. Okay. If they don't hire in this round, then again apply after 2 or 3 months. Try to be in contact with the HR. That's I am working on this thing. And in 2 months, what you have done. Okay. Always be apprehensive of whatever things you have done. Okay. So if you have learned a particular skill, then talk to them that, sir, I have upgraded my skills from this particular stage to this particular stage. Okay. So in that particular form and manner, I can see you that you are very diligent and you are learning day by day. So that will help you. Okay. And you have to make me understand that you are learning and your skills are growing. Okay. Nobody will just see your face and they will appreciate that the person is very intelligent or whatever the thing is. Okay. So you have to communicate. That is the foremost thing. You have to communicate, sir, that I was pursuing these many skills. and I have upgraded from this many skills to this much of information and skills I have acquired. Okay. In that form and manner, they'll be very interested to hire. Okay. For your and whatever the challenging projects are there, they are the most opportune projects for you to learn. Okay, for you to learn means the things which haven't been done yet. If you would be working on those projects, then only your learning growth would be very sharp, very steep. Okay, so this is the simple thing which you can expect. Okay, anything else?
No, and one thing, just last one.
Yes, 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 yes. Feel free.
In IIT Kharagpur, there will be any opportunity for internship. I heard one thing that in any NTPL course, who are the topper, they get
Yes,
opportunity
yes,
to work with the.
yes, yes, yes. That is the case. Whoever are the toppers, they are generally called. Okay, and they are given the stay for 1 and 2 months, and they are given the internship opportunities. Okay. If you particularly talk about IIT Kharagpur, then please follow our recruitment page. Okay. A lot of project positions are also there. They are projects JPO, Joint Project Officer, SRF, JRF. These type of positions are all already there continuously. Okay. Continuously, they are getting advertised. Okay. In my department only, agriculture department, AI engineers are being hired. Okay. So if you are interested and if you like the pay scale which they provide, then feel free to join us. Okay. That is it.
Okay, sure, sure.
Oh,
Thank
then let oh, okay. Then let us move to our present topic. Okay. The goal of computer vision is very simple. It is to replicate human vision capabilities using machines, okay, and achieve the tasks: object detection, image classification, object tracking, scene understanding. Object detection simply means, okay, in a scene or in an image, you have to identify whatever is the shape, size, and dimensions of a particular object. That is your object detection. Image classification. Image classification is, first of all, you have to understand a image has been provided to you. You have to feature extract the image. Okay. And on the basis of the features which you have extracted, you have to classify what is the image. Okay. What is the image? What object it is there, and another thing is object tracking. A continuous video is there. And in that particular video frame, you have to, first of all, track a particular object. If I am moving likewise, okay, likewise, my head is tilting in both the directions. And if I apply some object tracking algorithm, then first of all, it will detect the key points. Okay, key points are nothing but but the video markers. Okay, so 1, 2, 3, 4. So likewise, on my face, some key points would be there. They would be marked, and those key points would be tread in your X and Y direction. Okay. And when it comes to AR and VR technologies in those particular fields, X, Y, and Z, in all the three directions, you have to put the markers and continuously track them. Okay. This is regarding object tracking. Then it comes to your scene understanding. Scene understanding means a uh, particular scene or particular image caricature has been given to you, and you have to just observe and just say what is about those particular fields. Okay, what do you understand or what do you infer from that particular scene? That is your scene understanding. Okay, I'll take a 2 minutes break. Okay, and I'll come after that. Meanwhile, you can just think of whatever the other uses are there and what are the goals which you can just try to perceive from your computer vision. Just give me a 2 minutes break. Okay. Actually, the thing with me is that a lot of things go hand in hand. So presently, just I was just accessing Param Shakti supercomputer. So whenever a notification comes from it that your job is done, then I have to go to other lab. Then I have to upload another task for the analysis. Okay. So big data analytics is the key research domain. Okay. And that is only possible with the help of the supercomputers because our computers, whatever the generations are there, how much GB RAM and ROM we purchase of, they are not of use because big data is in TBs. Okay. So when it comes to their analysis, then supercomputing is the only thing which you can think of. So that is the thing. Whenever a notification comes, right now my mail is also open. You can't see it, I can see it because I am using three simultaneously screens. Okay. And whenever a notification comes, then I have to go to other lab, then I have to set up that particular job profiling, and I have to create another job so that the next part of the data get uploaded. Okay. So this is the facility which we have got and we are currently using it for the data analysis as well as model training purposes. These all are vision models only. Okay. Why I am telling you because in all the 12 weeks I have to be very strict, but in today only I have taken liberty so that I can explain you my work also. Because the ultimate goal is for you to either understand the thing in whole. Okay. It is not like that in parts you will understand some mathematical formula and implementation. You have to understand each and everything. Then only you will be interested in working on some computer vision domains or any domain which you are pursuing. Okay. So if you want to actually work and actually see something which will be useful for the humanity, then you have to keep on just pursuing this particular field. Okay. Even after the course is over, you have to think of the use cases which you can think of. Okay. And always try to be innovative. Okay. That is the thing. Whatever things that has been done till yet, okay, take inspiration from them. But don't restrict yourself. Sir, this is the limit. Okay. This is not the limit. Okay. Limit, uh, I don't think so that there is any limit. Okay. When it comes to your computer vision, when it comes to your any domain capabilities. Nowadays, see, each and every record is getting broken. Okay. And the learning graph and the technological development graph is is exponentially high. Okay. It was in if you I tell you till 1900s or till 1800s, it was linearly progressing, and before that it was straight line curve. Okay. So technology was not getting so much advanced. Okay. But after 1800, the progress which we have seen in technological development, and after these years, after late 2020s, we have seen exponential rise. Okay. So you are the next generation, you are the current generation, which should take the lead. Okay. Then only you can contribute and you can be a master of your field as well as you can contribute something to the humanity. Okay. So that should be your goal. Okay. And always try to think of the use cases. Okay. Whatever things you are learning, try to think of the use cases. Okay. So thereby uh, you would be more interested about the field. Okay. As well as you would be very thorough with the concept whenever you will think of the use cases. Okay, that is the then how computer vision works. It works on the basis of image acquisition. Okay, it works on the basis of image.
Sorry to interrupt you. You said
Yes, 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 yes.
that you already told that you are working some projects. So any recent new development you have created or something that you made as
Any
doing?
recent developments, whichever I have created, that you can see on my Google Scholar profile. Okay, we generally publish paper on the things
Okay.
which we generally work. We our main intention is to either publish a research paper or go for a IPR. Okay, intellectual property rights. Either we will file a patent on that. Okay, or any other thing, whichever will come. So if you just see here, if you are interested, that's what you have done, then I can just say, first of all, go to Google Scholar. Okay. Then type here this thing. Then you will get my profile. Okay. And then you can see whatever the things I have done. Okay. And if I try to explain you, this is the latest development which I have done. I have published a paper on this. Okay. This one, this one is not on computer vision. This one is on computer vision. Okay. This already I have explained you if you would have joined. And this one I have written. Okay. So I'll explain you this one in brief. Okay. In this particular domain, I have done the weed classification. Okay. Weed image classification, whether an image it is of weed or it is a of crop. Okay. This binary classification I have done. And what are the things I have incorporated? I have involved generative AI inside it, and I use LDDPM model and winner filtering approach. Okay. These both the approaches I have used to generate images of the weed as well as crops from a limited data set. So the model training is multiple folds enhanced. And with the existing models, when I have applied those this particular concepts, then I have been able to increase the efficiency up to 95%. Okay. So you can go through it. It's an open access paper. You can read it. Okay. And I'll explain you in brief. Okay. This is the latest development. You are asking about the latest thing which we have gone through. This is the latest development which I have achieved. And these are the images which I am able to generate using generative AI. Okay. So you can see the quality of the data set. And then I have retained the model and I am able to increase the accuracy up to 95%. So a lot of developments are there. Okay. So it is not like that I
So,
can
so that will be what type would are classify that development?
that the please repeat.
So, that development are based on what type image or what type trees are.
The quality of the images and everything is there in my table. I'll just show it to you. See here, this is the description of the data set. Okay. So first data set is deep feeds, then soybean wheat data set. Okay. I think it got hang. Just 1 second. Just 1 second. I think my system just got hanged. I am stuck here. I don't know how to get out. Yeah. I think now it is there. Yeah. You can see here the data set which I have used, I have given the links of along with the total number of images. But the thing with this is that the accuracy which I am able to achieve, that is not very remarkable when it comes to real field applications. Okay. That is why I have used the generative AI as well as these filtering and narrative approaches in order to increase the accuracy. Okay. That is the thing. Any other thing?
Okay. So
Okay.
what is the use case this?
Use case in this is weed crop classification. Okay. If any
Okay.
image is given to my model, then it would be able to classify whether it is a weed or it is a crop. And use case this can be applied in autonomous weeding operations. Okay. Autonomous weeders are coming which are having computer vision models fitted inside that. So I try to train that particular model which can classify an image into a weed or a crop. That is the use case. Okay.
Yes.
So if I try to explain you how computer vision model works, it works first of all by image acquisition. Okay. Capturing images or videos through sensors or the camera. Then after that, pre-processing is there. Pre-processing is step in which you would be removing the noises, would be resizing the images. Okay, resizing images means image size if it is too large. Okay, if the image size is suppose say 1024 multiplied by 1024 pixels. Okay, it is a too large for a model to interpret. Okay, so then you try to resize, you try to reshape that image and try to decrease the size of the image from 1024 to suppose say 256. Okay, 256 cross 256. That is resizing, resizing the shape of the image. Okay, then it comes to normalization. What is normalization? Okay, first of all, you have to understand then every data which you would be receiving, it won't be the same. Suppose if I go through the entire data set and I found that the color ranging is varying too drastically. Sometimes in my data set, some of the images are there which are just taken in night, and then some of the images are there which are taken in very lighty conditions, okay, and the brightness is too high. So in those particular cases, you have to go for the normalization. Normalization is nothing but the process in which we try to normalize the entire data set. Means try to scale up, scale down, or we try to achieve a uniform data distribution throughout our entire vision model. Okay. So that is your normalization. Then feature extraction. Feature extraction is nothing but identifying the edges, shapes, patterns. Okay. That is your feature extraction, in which in those particular cases you have to identify whatever the edges are there, the shapes are there, the patterns are there in the entire image which you are receiving. That is your feature extraction. Three features I have mentioned here: edges, shapes, patterns. A lot of features are there. Okay, so key point is also a feature. Okay, so a lot of features are there, and nowadays each and every day with the advancing research domains, you can see lot of uh, another things which are getting developed. So that it comes to feature extraction. After that, the step is model training using machine learning, deep learning algorithms, or whatever the algorithms you feel. Okay, they are done for model training. Okay, means a computer vision model would be there. Okay, that will try to train or try to deduce some mathematical relations on the basis of the data set, on the basis of the parameters which you have provided, and then after it is trained, it would be working on the unknown data set which you will provide later on. Okay. Then prediction and interpretation. Yes, it comes to classifying, detecting, analyzing visual input. That is prediction and interpretation. Okay. Then we'll try to see what are the key techniques. Somebody asks you for image processing, for filtering, for edge detection, for segmentation. These are the techniques. Okay, these are particularly contained towards image processing. Okay. Then feature detection. What is feature detection? Feature detection is nothing but detecting the useful features from a given data set. Okay, they can be of anything like your contours, like your facial contours, like your edges, like your HSV saturation values. These are the features which are detected and they are matched. Mathematically, they are matched. Then it comes to your deep learning, like see, deep learning and machine learning. What is the basic interference? See, machine learning typically confines the models, mathematical models, which can do regression and analysis. And after regression and analysis is fails or we want further enhancement of the accuracy, we go for deep learning. And in deep learning, the very first thing is artificial neural network. Okay. From artificial neural network comes your CNNs, comes your RNNs. These are nothing but structured artificial neural networks. Okay. And transformer models, I'll try to explain you in brief in this particular session only. These are the most advanced models which are currently being used. Okay. Then comes your 3D vision. 3D vision means 3D camera would be there, and that 3D camera would be capturing entire view. Okay, the view of the world in entirety means it would be capturing the world images in three dimensions. Okay, and there would be a depth perception also. Okay, then comes your optical flow. Optical flow means what is meant by optical flow, what is meant by motion analysis. Optical flow is very simple terms. I try to explain you when it comes to your augmented reality and it comes to your virtual reality. Then you have to increase and decrease the optical intensity of intensity of various LEDs or LEDs only in sequence and series. Okay, so that only particular manipulation of the light intensity of the LEDs that would be creating a perception of depth. Okay, so that you would be able to achieve only with the computer vision. As well as when it comes to your motion analysis. Motion analysis means nothing but see, particularly in our domains, in when it comes to the computer vision, we have to give a useful interpretation from the information which we are fetching. So motion analysis is nothing but your analysis of the feed in entirety. If I am speaking, then with which velocity my lips are moving, if you are able to just tell it, then you would be able to tell that then you will be able to tell what other words I'll be speaking. Because if you just train a model that after which word I speak another word and whatever is the lip movement, okay, and take them as a dependent parameter and take another parameters like what is the timing, what is the person's height, and those parameters as independent parameters, and you try to create a computer vision model on the basis of that, then you can create a 3D caricature just like me. Okay, that he will be explaining you these things just like me. Okay. So nowadays advancements are so much so that AI avatars are there. Okay. So they talk just like humans. And how they are able to do that, that is only possible because motion analysis has been carried out. Okay, with human interpreters, with human teachers or human beings. Okay, so this is the thing which you can just think of. Okay, and don't confine yourself to these techniques. Now, new techniques are coming day by day, so be well versed with those also. Okay. Next, what is machine learning? What is the difference between machine learning? What is the difference between machine learning and deep learning? Machine learning requires manual feature extraction. Deep learning will automatically do that particular process because here artificial neural networks and multi-layered artificial neural networks are involved. And several algorithms are being used like your SVM, your KNN. Okay, already the mathematical aspects we have covered. And in deep learning, the deep neural networks are there. Okay, multi-structured neural networks or deep neural networks are used. For example, your CNN, convolutional neural network, regional CNN, RCNN, YOLO, YOLO convolutions. Machine learning basically works for simple tasks. Okay, if I image I have provided to you and I just ask you that what is the size of the image that you can always quantify through machine learning or what is the pixel density that you can quantify through machine learning. But if I want to go for object detection, custom object detection and the whatever things I have mentioned, then you have to go for deep learning because it is meant for handling complex visual tasks. That is your deep learning. Now you see what is machine learning types. Okay. Machine learning is basically quantified into supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Okay. These are the basic types of machine learning. See, machine learning in itself is a course, and in future, I hope that I will be taking that also. Okay. So I'll try to be very brief. Okay. But it is your responsibility that as a student of science, okay, you could be very thorough with machine learning, deep learning, and artificial intelligence, along with it, computer vision. But here, since the time limitation is there, I try to be very brief. Okay. In your supervised learning, there are two particular categories: continuous target variable, categorical variable. Okay. Continuous target variable is nothing but in those particular cases in which you perform the regression analysis, okay, on the continuous data. And categorical target variable is those particular cases in which you classify. Okay, and to classify the data into two categories or in three categories on whatever number of categories are there. Okay, that is your supervised learning. Continuous target variable, categorical target variable. Then it comes to your unsupervised learning. In case of your unsupervised learning, the thing is two particular domains are there. First of all, it is clustering or it is association. Okay. In your unsupervised learning, okay, target variable is not available or it is not defined. That is the thing. Okay. Then in case of your semi-supervised learning, both the classification and clustering approaches would be used simultaneously. Okay. And thereby you would be able to see the particular categorical classification. Then in your reinforcement learning, a particular learning function is there which will try to penalize the wrong output that is there in your reinforcement learning. And uh, after preparation, the model accuracy is increased multiple fold times. That comes to your reinforcement learning. Next, you try to see the most complete chart of your neural networks. Okay, the title is like this, but indeed is the most complete chart of your neural networks. Whatever the type of neural networks are there. See, in here it is mentioned what is the different types of layers. Okay, and different types of layers, what are the connections. Okay. So if you try to see here, the first uh, type of neural network is multi-layered perceptron, okay, or perceptron neural network. It would be only having input and output layer. That is the thing. In case of your feed-forward neural network, okay, feed-forward neural network it would be having input layer. Then there would be another layer, hidden layer, and after that there would be output layer. So that is your feed-forward neural network. After that, there is another type of neural network that is RBF, radial basis function neural network. That would be having input layer, hidden layer, and your output layer. And whatever the connections are there, they are almost same as feed-forward, but that really difference which you will see is there in your transfer functions. Then deep feed forward neural network. And only the thing is there's that the number of hidden layers has increased. Rest all the things are same. When it comes to your RNN, recurrent neural network, there are input layers, recurrent cell are there. These are also just like your hidden layers. And after that, there would be output cell. Then when it comes to your LSTM, long short term memory, there would be input layer. Okay. There would be recurrent cells along with your memory cells. Okay. Not recurrent cells, there would be your memory cells. Okay. See, in LSTM, a particular feature is there that memory is just introduced. Okay. Memory is introduced. What do you mean by memory? See, when you are training a neural network, some of the times it will there would be losses. Okay. When there would be losses, when there would be inaccuracies, the neural network has to just identify those directions in which it has to produce in order to minimize those type of losses. Okay. So that is why we have provided a memory sense inside the hidden layers. So the penalty which would be imposing for the wrong decisions that would be taken into account in the memory, and the next time whenever the operation is executed, then those particular mistakes will not be done. That is your LST. Then you comes to your gated recurrent unit, GRU. That you see. Gated recurrent unit would be somewhat different. It is having your differential memory cell. Okay, differential memory cell means, see, when you are training neural network with dependent and independent parameters. Okay, in some of the cases, what the thing will happen. Just 1 second. Yeah, in some of the cases, the thing which will happen. Yeah, in some of the cases, the thing which will happen. you just try to understand it. What is the basic of your weighted recurrent unit? In some of the cases, uh, during your neural network training, what will happen? That whenever you would be running your training process after say suppose 20 pokes, the thing which happens that some of the parameters, okay, they are super saturated, means their influence after training neural network for certain period of time becomes negligible. Those particular cases you have to just reduce their influence on the training procedure. Okay. So this is a very advanced type of neural network in which we generally differentiate the memory cell. The memory capacity of those particular neurons, they would be hidden. Okay. So that is why I am saying here differential memory cell. Okay. Because when reducing the memory weightage of that particular cell. That is why I have written here differential different memory cell or differential memory cell. Yeah, that is it. Now you see the latest development which we have seen is your nothing but autoencoder. Autoencoder is very useful when it comes to your training your LLMs. Okay, large language model, because the thing it will ensure is that it will just try to imbibe the it will just try to inculcate the output parameters. Okay, it will just try to inculcate whatever is the output parameters are there. But on the basis of the output parameters, it will try to retrain as well as re-influence the neural network model. Okay. So whatever thing is happening that some in all of the neural networks which I have explained till here, okay, they are having fixed input and fixed output. Okay. So inputs are predefined, and well as whatever the outputs are there that are also predefined when it comes to your training data. But autoencoders, the main difference between all these type of neural networks and autoencoders is that they try to modify themselves automatically according to the outputs which the person wants to achieve. So whatever the number of hidden layers would be there, whatever the number of transfer functions would be there, whatever the nature of transfer function would be there, that only would be self-optimized. That is the case with your autoencoding. Okay. Then when it comes to your variational autoencoders, denoising autoencoders, and sparse autoencoders, these are the newest use cases of your coders. So they are just meant for specific purposes. Okay. They are meant for handling specific tasks, and same modification we are trying to perform on the input of. Okay. Now you try to see popular algorithms and models. The most popular one is CNN, convolutional neural network. Foundation for image recognition, then YOLO, you look only once. Okay. For real-time object detection, deconstruction, construction, all of these things, YOLO is the newest model. Then comes your RCNN, fast RCNN, masked RCNN, which is region-based detection. Then OpenCV is there. This is the popular open source library for computer vision tasks, as well as your VIT, vision transformers. This is the modern architecture, which is inspired by natural language processing. What are the applications? Applications you can see here in healthcare, agriculture, security, automotive, retails, robotics, entertainment, infotainment, everywhere. The particular application is there of computer vision. Okay. Then one example is there for YOLO. Okay. It detects multiple objects in real time. It divides images into grids, predicts using the bounding boxes for autonomous driving, for surveillance and robotics. This particular vision modeling is nowadays very useful. Okay. What are the challenges in computer vision? Variation in the lightning angle, background. This has always been a challenge. Okay. And we have to apply various filters based on our data set before we can just superimpose any particular image process modeling. Then another thing is your partial visibility, okay, or your occlusion. That is your another challenge. Then real-time processing speed. Yes, this is another typical type of challenge, real-time processing speed. and requirement of large stable data sets. Yes, it is also a challenge. Ethical and privacy concern in your data usage, it is also a challenge. These challenges are there for various other domains. Same type of challenges are there, but processing speed and as well as variation in the data set, these are the major challenges of computer vision. And recent trends are vision transformers, then that DETR, okay, then self-supervised zero shot learning, okay, then 3D vision, AR, VR, neural radiance fields for 3D reconstruction, then edge AI, okay, incorporating AI with the computer vision modeling, okay, so that the accuracy with over time will be multiple folds enhanced. Okay. The tools and frameworks which I have already demonstrated to you is OpenCV, TensorFlow, PyTorch, Keras, and YOLO. In this particular course, I have not demonstrated to you particularly, but you can implement it with bit of stone tool. Okay. As well as MATLAB computer vision toolbox is there, but the thing with this is that if you will apply those, okay, then the thing with this is that it is not uh, getting updated. Okay. With the due course of time, it is not getting updated. That is the only disadvantage with MATLAB computer vision toolbox. Okay. It should also incorporate the latest computer vision models, like it is already embedded in your Python. Okay. That is it. Then a brief introduction about types of transformer models. Okay. Encoder only transformers are there, decoder only transformers are there, encoder decoder transformers are there, mass language models are there, auto-regression models are there, and computer conditional transformers are also there. Okay. These are different types of transformer models that are trained for accomplishing different tasks in your neural network modeling. Okay. This is different types of models and tasks also ahead of that I have written, so you can go through it. Okay. But the architecture is very, very important that I'll try to explain. Okay. Main points of the architecture are this. Okay. See here, first of all, only two parts are important for us. The first part is your encoder, another part is your decoder. Okay. In case of, if I try to explain you in brief, what is encoding? Encoding means, first of all, you have to generate an input sequence, you have to fetch the input data, then you have to tokenize it. Means directly you are not undergoing any processing. Okay, with with the data which is fetched. Okay. You are tokenizing it, means creating small patches from the input data. After that, you are embedding it, means you are giving it to the model. Okay, using some pre-defined value. Okay, then that would be having key, value, and query, similar to the two-factor authentication. Okay. So would be there, values would be there, query would be there, and particular attention head would be there. Okay. After those particular things are achieved, then multi-head self-attention is carried out. What do you mean by multi-head self-attention? Self-attention means encoding. After encoding, the entire information which we have received, now it is processed. Now it is processed, and during this process, we have incorporated some of the mathematical manipulation which has reduced the computational complexity to such an extent that now you can divide the data into various tokens. Okay, and then you can interpret on the base using your multi-head self-attention mechanism those particular data patches. Okay. And just if you have encoded some information, then you have to decode also. That is carried out using the reverse procedure which we have done for encoding. And after encoding and decoding is carried out, okay, then after your means encoding is taking from one channel, decoding is taking from another channel, and the out encoding and decoding, when they are coupled, okay, when they are coupled using your self-attention mechanism, then we achieve the output. The reason behind the successful implementation as well as the successful execution of the transformer models is this particular thing that you try to remember in brief, that encoding and decoding procedure happens simultaneously. Okay, and uh, it is just pre-trained as well as it is just uh, manipulated real time by seeing the output and seeing the results which you want to achieve. That is the main reason why transformer models having such a strikingly high accuracy rates. Next, moving forward, very sorry because I can take a full lecture on this transformer architecture. But the thing is this, that since we are having time constraints, I am trying to cover as much information as possible. Okay. So if you are interested, then feel free to contact me. Okay, for some project or anything. I've already provided my mail ID. Okay, as well as the recording, PDFs, everything I have tried to give you. And if some doubt is there regarding the examination or anything is there, I'll try to explain. Next, we have to move forward. Okay. Yeah. See here, when you are using the computer vision modeling, okay. So encoding and decoding is kept getting simultaneously. Okay. First encoder is there, then second encoder is there, third encoder is there, fourth encoder, fifth encoder. Similar chain would be with your decoder also. Okay. And these are multi-head attention. Why we have not used single head attention? Because of the fact because we are creating multiple tokens from the basic input data set which we have. Okay. It is why we are going for multiple head attention mechanism as well as addition, normalization, then feed forward. Okay. And inside, after achieving all of the looping procedure, we are achieving the okay. And this is the entire journey of YOLO models. You can see here yourself that latest model is YOLO V12. Okay. I don't know whether V13 or V14 is also just has come into the market, but these are the models that have been tried, tested so far. Okay. So latest development we have seen in February 18, 2025. Okay. So YOLO V12 just came into existence. Okay. This is the entire chainography. And I think for most of the industrial cases, they are currently confined till V5. Okay. Industrial usage is something else, and your vision model development is something else. Okay. Both domains are totally different because when you are going for industrial mechanisms, okay, then their inference time and accuracy both they have to that have to be as high as possible. So they are going for modern manipulation also. They are changing their convolutional layer. They are changing their everything. After that, they are coming with the final model, which would be suitable for their task. Okay. So that is the thing. What would be the future use in future? Robotics and autonomous systems would be there. They would be combining those particular techniques, computer vision techniques. There would be real-time human-computer interaction. There would be enhancement in medical diagnosis. There would be explainably and explainable and ethical AI vision systems. Okay, this is the future as far as I can see, I can feel. And in summary, computer vision enables machines to see, understand, act on visual input. It is powered by deep learning and large data sets. Okay. It transforms multiple domains from healthcare to agriculture. It is still evolving. It will continue to evolve. Okay. Then coming to next part. Okay. Computer vision enables machines to interpret visual world. Okay. Input is images or videos. Output is description, classification, decision. It is based on mathematical modeling, image processing, deep learning. Pipeline is just like this: acquisition, after that pre-processing, after feature extraction, after that learning and decision. Okay. Friends, you just have to understand that everything, whichever is happening inside a computer vision model, it is taking image as a mathematical function only. Okay. An image is nothing but a 2D discrete function and it is defined as f of x comma y. And for color images, it is nothing but your three-channel image, a three-channel function. RXY, VXY, BXY. RGB are the three different pixel intensities. Okay, with uh, a particular pixel value. Okay, at a particular uh, suppose 1 cross 1 image size is there, it would be having infinite number of pixels. Okay, each and every pixel value would be having three parts RGA. Okay. Then digital image is the sampled and quantized version of the real scene. Okay. Then for spatial filtering, you can see the function. It is mentioned here for your Fourier transform. This one is the function for your edge detection. I have already explained you in week 12. In not in week 12, in I think week 4. Okay. This along with the particular numerical question I already have covered. Okay. In week 4, you can go through it. Okay. Sobel, Kenny detection, and whatever the mathematical aspects I have covered those in great detail. You can see there. Then for segmentation, thresholding we have seen. We have also seen k-means clustering. Okay. Then we have used contour methods also. I have not covered contour methods. Okay. Particularly through numerical question, but I tried to explain you in brief. Okay. When your spatial filtering fails through all of these methods, then we apply some abstract contouring also sometimes for feature extraction as well as feature filtering. Okay. That is the use case of your contouring method. Okay, in which we try to make the contours, and on the basis of the contours, okay, special arrangement of the contours, we try to conclude what is the dynamics of the data. Okay. Then this one is the Harris corner detection. Okay, determinant of M, where M is the structure tensor minus K times trace of M whole square. Then shift we have seen scale invariant feature transform mathematical aspects. Then one advanced form of shift is there, which is OR and surf is there. That also we have seen in great detail for real-time feature extraction. Okay. I hope you will go through the mathematical aspects. You will prepare the numericals also. Okay. Then for your object detection, okay, SVM and KNN, okay, K nearest neighbor and structure support vector machine are there, and the transfer functions which they use for maximizing the margin as well as classification of the nearest feature vectors, they are mentioned here. Accuracy improves using deep CNNs with learn hierarchical articulate features. Okay. So whatever the number of hierarchical features you would be enhancing, that would be leading to your increase in the accuracy of the particular model. Then CNN, what is the convolution operation that you can analyze here? Yesterday only we have solved a particular question related to RCNN, where I explained you in great detail that how your vision modeling or how your during your vision modeling, okay, this particular convolution operation is carried out. Okay, particularly in case of your RCNN model. Okay. Then comes your activation. Activation is here, it is mentioned as the defined linear unit or value activation functions. You can go through different types of your activation functions like sigmoid, time sigmoid. Okay. Then comes your pooling. Okay, reducing the spatial dimensions. Okay. Then this is your top one accuracy. Okay, top one accuracy as well as the operations of whatever are the computer vision models. These are they already have been developed and they already have been tested. Okay. And you can see here various computer vision models have been developed for various tasks. These are the models. Their number of parameters are less as compared to the YOLO models or the transformer models. Okay, those latest models they are having too many number of parameters, trainable and non-trainable parameters. That is why the accuracy is supersedes there. Okay, with the latest YOLO model, sometimes during training, I have particularly seen that the accuracy is of 98, 99%. But here you can see only NASNet large. This was this particular model, it is only able to achieve more than 80% accuracy. While all rest of the computer vision model, they are nearly having 80% accuracy. So this particular one is the use cases, okay, related to your top one accuracy and your operations. Okay, operations are generally measured in your gigaflops. Okay, floating operations per second. Then if I tell you here in brief what is CNN, okay, this one is the correct picture pictorial as well as layer 5 classification of your CNN, a convolutional neural network. Okay. First, the thing which you have to understand is your input. Okay. After input is done, then we go for convolution. Convolution is the same operator that we have used in the previous class. Okay. Then we go for transfer function analysis, that is rectified linear union. After that, we go for pooling. Okay, pooling can be maximum max pooling, it can be minimum pooling. Okay. After that, we are done for flattening layers. Okay, flattening layers means from a two collection of layers of or the width of and across the entire width of the uh, layer step. Okay. Some particular manipulation is carried out at each and every layer in order to minimize the number of features. Okay. And obtain useful information from those particular layers only. Those are having greater number of parameters set to a particular threshold. Okay. That is your pooling and flattening. After flattening, there are fully connected layers. Okay. Fully connected layer, they would be classified here, and they would be means their input layer and hidden layer after input and input operations. Okay, these are carried out. Then this particular information is transferred to the fully connected layers. Input layer, then hidden layer, then output layer. And from the output layer, first, if you have provided transfer function in the junction between hidden layer to output layer, then you have again apply the transfer function in order to obtain useful information from the mathematical attributes which have been achieved. Okay. Then the stepwise execution is feature extraction. Feature extraction after that classification using artificial neural network or deep neural network. Then there is probabilistic distribution. Okay, which particular data set is which particular probability is there? Okay, related to that particular. Then comes your mathematical model of your CNN layer for the input picture map X and a filter W. This one is the mathematical relationship. Okay, that we already have seen. Okay. Then YOLO mathematics, if I try to say here, okay, if a image grid is there of S by S size, okay, and bounding box width and dimensions is X, Y, W, H, confidence is 4 is there, class probability is there, okay. Each of the grid would be having this particular feature. Okay, bounding box will be formed and aside of it, a confidence score would be there that denotes to the probability. Okay, how confident the model is that this particular object which is there inside the bounding box belongs to a particular class. Then comes your class probabilities. Yes, classification is always accompanied by class probabilities. Then there is a loss function. Okay, loss function is defined like this. Already we have seen a particular numerical. Okay, in our previous session in week 12, we have solved a particular numerical. Okay, then just moving forward, what is the mathematics behind the optical flow and motion estimation? Motion estimation, optical flow will try to estimate the pixel movement between the frames. Okay. And it will automatically provide you the brightness constancy on the basis of the estimation of optical flow. And in linearized form can be solved using Lucas, Kennard, and Horn-Schnuck methods. They have not covered in this particular course. Just for the sake of information, I have written here. Okay. Then in your 3D perception, 3D vision and depth perception, we already have solved a lot of numericals in your studio vision geometry. Okay, we have seen a lot of numericals and a lot of mathematical attributes related to your area within geometry, in which we have defined depth, okay, using this particular relation f capital B over small d, where f is the focal length, b is the baseline, d is the disparity. Okay, and it is used in autonomous navigation, SLAM, and AR/VR. Okay, this is the thing. Okay. Then mathematical modeling in 3D reconstruction. Okay, these are the projection equations. Okay, when we try to project a uh, particular perception or a particular set of points in 3D space, when we try to do with this type of mathematical manipulation, in which we apply rotation and translation mathematics simultaneously for your camera calibration, for your mapping 3D scenes. This particular technique is very, very useful, in which you take a particular object from XYZ coordinate and and you try to export it, okay, in another coordinate frame of reference, and we have covered many numericals on this particular concept. So then comes your evaluation metrics. Yes, there are evaluation metrics involved also. Accuracy, precision, recall, F1 score, everything is there. Okay. And IOU is there, intersection over union, in which we try to form the overlap area and divide it by union area. Okay. And we try to interpret on the basis of that particular information that our model training is going in which direction. Okay. Then mean average precision is there. This is a standard for object detection tasks. Okay. For the entire consistency, mean average precision is very. Applications are medical imaging, then agriculture vision, autonomous vehicles, industrial inspection, and defect analysis, and robotics. Okay. Challenges are high computational cost. Still, it is a challenge, and what challenge is there, that with the increase in the computational complexity, the greater the accuracy would be there with the computer vision model. It will require greater computational power also. Okay, so hardware cost automatically will increase. That is the major challenge with this. Okay, and dataset biasing is there, labeling errors are there, then variations in illumination and perspective are there, and real-time constraints, embedded deployment is there, ethical and privacy issues are also there. Legal challenge, specific challenge. Then future directions. Okay, in the future, we can see vision transformers, self-supervised and few shot learning, then integration with neuromorphic edge computing. Okay, quantum vision modeling. This is the high dimensional feature specs spaces are there, in which you are not perceiving an image in three or four, in two or three dimensions. You are processing an image in more than the three dimensions. So the future, if you want to know that whatever the models they would be coming, they would be more and more towards your high dimensional feature spacing using using quantum model. Next, this is the conclusion. Computer vision blends mathematics, artificial intelligence, engineering. Core foundation is always linear algebra, calculus, optimization, probabilistic approach. Okay, probability. It enables machines to perceive, interpret, and act. Okay, and it is key for robotics and autonomous systems. And references I already provided. Okay, the book which I prefer is this Zelensky, Computer Vision Algorithms and Application. Next book, if you want to see, is Gonzalez and Woods, Digital Image Processing. Then Goodflow et al. For is a very famous book indeed for understanding the concepts of deep learning. And these are your OpenCV, PyTorch, TensorFlow documentation are very, very important when it comes to the practical application of computer vision. This is the end. Okay, thank you all, and you have prepared diligently for this examination. Have give it your best. Okay, and good luck. Okay, just to be in talking about in brief, I have prepared this particular formula brief sheet in which I have just provided all the formula. Okay, at a glance. With I'll just say here, pinhole camera modeling is there, then convolution filtering modeling. Okay, filter convolution and filtering, okay, and gradient based edge detection, then image segmentation clustering, okay, then your feature detection and description, then shift key point descriptor, then your deep learning foundations, okay, then backpropagation if you want to see here how really CNNs are just trained. Okay, Sarah has just provided a brief example related to your CNN modeling. If you go through our video lectures, there he has talked about this. Okay, uh, in brief. Okay, that is why I have not solved a particular numerical. Okay, during my your crowd solving sessions. Okay, but feel free to solve a particular numerical related to web propagation. Okay, if you find time. Okay, because this is very, very important. Okay. As well as this from 6 and 7 onwards. Okay, these are not particularly exactly covered. Okay, so if you want, you can visit these. Otherwise, you can leave this. Okay. In case of YOLO modeling, this one is the loss function, but the particular loss function that is negative LMPI. Okay, that was there in your previous class. That is very, very important. Okay, you can leave this, but you can be very thorough with that particular example, which I covered during my previous session, okay, week 12 session. Okay. Then this is the optical flow motion analysis. These are the equations. Okay, you can leave 6, 7, and 8 if you want. Okay. 6 you can understand in brief, 7 and 8 directly, exactly you can leave because that has one not covered in this due course of time. Okay. And yes, from ninth onwards, this is very important. Okay, from ninth onwards, these are important. So one second. From ninth onwards, okay, 3D vision, stereo triangulation that you can just remember, as well as optimization. It is a universal approaches. Okay, as well as evaluation matrices. What is precision? What is recall? And what is F1 score? What is IOU? And what is mean average precision? Then, what is the foundation summary? Linear algebra, calculus, probability, geometry, and optimization. Okay. So this is the formula in brief. Okay. Take a handy note of these. Okay. As well as you can yourself create a formula brief for yourself. Okay. In which you can just accumulate all the formula from week 1 to week 12. Okay. And that would be a very handy note for your exam. So this is the end from my side. Okay. Good luck for the examination. You have prepared diligently. Give it your best try. Okay. And I hope all of you would be passing the examination. Whomsoever would be just appearing in it. Okay. With flying colors. And all the best. This is the end from my side. Okay. And still half an hour is there. If you have any doubt in any portion of the examination or any doubt related to your academics, related to your career, feel free to ask. I'll be here for for half an hour more. Okay. Thank you all. It was a nice interaction with you all. I see a lot of enthusiasm. Okay. And I'm very, very thankful to you, whomsoever joined and try to interact, try to enhance your knowledge. And with your knowledge, my knowledge also got enhanced. Okay. Because teaching and learning are two simultaneous processes. Okay. In which the knowledge of teacher is also enhanced, knowledge of the student is also enhanced. Okay. So it was an honor. Okay. Teaching you all.
Thank you, sir. Thank you so much.
Thank you. Thank you so much. Okay. Thank you so much. Okay, and all the very best for your examination. Okay.
Yeah, thank you
Yes.
so much, sir, for all the classes. And if
Okay.
any future need, I will definitely connect with you.
Okay. Okay. Thank you. Thank you so much.
Thank you.
Hello, sir. Thank you for the sessions.
Okay. Welcome.
Yeah, can you please share that summary of the formulas? I am not finding it in that Excel sheet.
Yes, I have just shared. Just check the link. Okay, you would be finding that. Okay. Just a minute before I have shared. Refresh the link. You will find it.
Where it is?
It is there in the link. This doc link I have provided to you, right?
Okay,
You,
okay.
yes, just click it. Inside there, beside my name, a drive link is there. Just click it
Uh-huh.
and you will
Okay, okay.
find. Yes, yes.
Yeah, I already opened that. The last one is it? Summary. I am not seeing the summary.
Okay. It would be there. Summary session.pdf and formula brief.pdf. I've just uploaded it. Can you see it?
Okay.
If you are not able to find, I'll just.
Yeah, formula. Yes, I can see it.
Oh, okay. Okay, then. Oh. And how is your work going?
Yeah, I actually I'm out of station now.
Okay.
It is out of an emergency here.
Okay.
I'm at
Okay.
my native, so I couldn't focus much on the sessions.
Oh, okay. Okay.
Hmm.
No problem. You were telling in the initial session that you were working on some research paper and
Yeah,
you want.
yeah. So I had
Okay.
to resume on that again. I
Okay.
couldn't
Okay.
focus on that. Plus my office work and this
Okay.
emergency, so I couldn't
Okay.
focus on. And I was on leave most of the time.
Okay. Okay.
Yeah, I'll get you connected. It's a few days maybe.
Okay. 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 Feel free
Yeah,
to contact. Okay. In case
yeah, that will
some
be
help is
quite
required.
helpful. Thank
Yeah.
you for reminding me, sir.
Okay. Uh, I'll be more happy to contribute. Okay. Yeah.
Sure. Thank you.
Okay.
Bye.
Okay. Bye. Have a great
Thank you.
Okay, thank you all. I'm ending the session. Okay, and so thank you and all the best for the examination. Thank you. Thank you.